Dooby 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 doo. Dooby 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 doo. Dooby 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 doo. Dooby 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 doo. Hey, we got sound. Hey, that was the intro music. Do you like it? Yeah, I know. I do it myself. Okay. Here we go. So, what are we up to today? Hey. I don't know. Rust project with SFML. Oh. Okay. Setting up a sandbox environment. Well, to develop an application. We're going to do our first application, aren't we? Alright. So today, we're going to set up an expandable project. That's important because we don't know how big our project's going to be. We don't even know what our project is going to be. Set initial goals. That's fine. Thinking about that right now. We can try SFML for the application development and implement a structured approach. I think we'll do that in reverse. Why did I write it that way round? That's probably just the way it came to me at the time. So implement a structured approach. Let's have a look at that first. All right. What do I mean by a structured approach? I think that if you've seen any of my previous streams or been on YouTube and had a look at them, you'll see that I tend to split things down into files, and I'll show you what I mean. So, from the last stream we did, last Sunday, we have main, and I've tidied this up over the week, so this isn't what you saw at the end. You saw just data files. I've now split it down into data files, save, and load. So we have data files, which checks the data directory. We have the save, which saves the data. And we have load, which loads the data. And that's a little bit better, really, for future development. If I want to change anything now, I can go to the file related to the change and just change that one file. It won't mean changing how it's used, hopefully. Well, not too much anyway. And yeah, that should work all right. Don't worry about the size of it. I'm not going over anything here. Right. So, what do we have? It's not simple enough. We can try SFML. Can we now? Right, I want to start this part a little bit differently. And we're going to talk not about Rust, but computer programming languages in general. So, computer programming languages in general, they offer you a way to program a computer. Now, mostly they all go about it in the same way. How long have computer languages been out? Well, ever since computers really have been out. But computers have changed. The languages haven't. The languages still offer the fundamental things that all languages offer. But if you're viewing this stream, then you're probably on a computer. If you're on a mobile, I do apologise for that. Let's just do this. Alright, that'll do. So if computers have changed, why haven't the languages? For example, if you're using a computer in modern day society, you're probably using some kind of a windowing system. Windows, Linux, Mac, iOS. I think that covers nearly 99% of computers today, doesn't it? Or computer devices. I mean, even your fridge has bloody Windows on it. So, why can't we open a window in a computer language? Why can't any of our computer languages just say, hey, create a window for us? And you'll find that most languages will be shipped, or one of the first libraries, or in Rust's case, a crate, will be, hey, open a window. Yeah, it's it's been left to the programmer. The operating system doesn't really handle it very well, as we've seen. Well, as I've seen. This is the Windows crate, isn't it? Oh no, this is the stuff I want to be using later. Ba 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 ba. Alright, that's a project. Yeah, Sandbox. We're going to talk about sandboxes in a minute. Ba ba. Yeah, Windows. This is the kind of thing that you have to go through on Windows if you wish to, well, open a window. Quite a lot of it, really. Yeah, 265 lines of code. Ish. And does not break out of loop. Yeah, with to-dos in it. Yeah. What's going on? Why are we left as programmers to do all of this? Shove it all into a library, make it easier to use, and then ship it out to other programmers and say, hey, look, you can do it quite easily now. Why isn't this provided within the language? Well, that's because there's different operating systems and the languages need to go on every single operating system. BOLLOCKS. That's not the reason. These libraries go on every single operating system. SDL, SFML. At that point, I become suspicious. Why haven't languages kept up with the times? Because the people developing the languages don't want to go that far. Is the answer. We can clear this, can we? Yeah. I don't want that load of rubbish there, thank you. Right, so I've got a fresh Visual Studio Code. We have the Rust Communities Crate Registry, and we're looking at SFML. What is SFML? Well, I also talked about SDL there, didn't I? Why am I not using SDL? Well, it's bigger. Simple as that. It does more. Probably more things I don't need. And that's the problem with these crates and libraries. They do a lot of things you don't need. So you are literally downloading quite a lot of code that you'll never use. So I tend to try and go for the smallest. Documentation. The simple and fast multimedia library. What does it do? It does audio. It interfaces with C++, because SFML is C++ or C. It does graphics, 2D graphics module, sprites, texts and shapes. It has a system module for various utilities. And it has a window module, yay! Which provides an OpenGL graphics library, the Open Graphics Library based windows and abstractions for events and input handling. So we've got events and input handling. Way, hey, we've got everything here. So that one module is what I would expect to find in any language. Interestingly, we won't find that module in any language. Yet. Interesting. I find it interesting. Why we don't? The whole of this should be in the language, as far as I'm concerned. We shouldn't be using a crate or a library to do all of this. But, yeah, that kind of thing is normal, I guess. Source, no. I'm going to go to the repository. So, Rust SML, Rust bindings for SFML, simple and fast multimedia library, which is written in C and C++. So this is why this is a bindings thingy. It means that we can use the C and C++ code from Rust. So it's not straightforward to use because we have prerequisites. CMake. So first things first, download CMake. Getting started, documentation, features. Get it downloaded, get it installed. Training. Getting started. CMake tutorial. Start here. Where's the download? Ah, there it is. Latest release 3.31.5. I don't think the release matters. Different platforms. Get Windows. I'm using Windows 64. So it's got an installer. I download that, run it, and Bob's your uncle. We've got CMake. I've already done that. Alright. So download and install that. Documentation. comes back to here, doesn't it? Oh, that's yuck. A wiki. Here we go. So get to it. Get to SFML's wiki, the Rust SFML's wiki. Obviously, build and try it. If you got CMake, you can build it. Yeah. Pages, no, okay. Windows. Okay. The gist of setting up SFML on Windows is to download the SML version matching your toolchain. Or your crate, not your toolchain. Which guides us to download SFML 2.5.1. You click on that, and of course, depending on what you're using, you just click on the download. Visual C++ 15. I went for the top one, I think. Just downloaded it and then dumped it on my C drive under just libraries. So here it is, 2.5.1. You'll notice I've also got SFML 3.00. Don't download that. Don't download the one it's asking you to. Okay, because otherwise when you compile and try and run your program, it's not going to work, because these are different, very different. So we've got the correct SFML. What else do we need? By the way, when you download it, it's probably zipped up or something, so you do have to extract it. And then I just place it anywhere, but usually my C drive under something like library. And inside you're going to find a bin, doc, examples include libs, all the kind of normal things that you would expect to find. So it's got full docs in here. That's nice. Don't think I've ever looked at them. Oh, it's HTML. That's nice. So you can browse through that in your browser. Very, very nice. So we've got that. We've got CMake. We've now got SFML. Quite happily sitting around on our computer. Then you can set up your environment variables. Well, down here is a little search thingy. Type in env, and it comes up, edit the system environment variables. That's nice of it. Thank you, Windows. And in the bottom right hand corner we've got environment variables, so we're going to click on that. System variables is, for me, the bottom square, not user variables for DAOC. If anybody knows what that means, well done. So we have to set some variables. SFML include directory. Yeah, I've already done that. There we go. SFML underscore include underscore directory. Browse to directory, to the include directory within. For me, it's the library SFML 2.5.1 and / include. That's all that's there. No backslash at the end, just / include. And that one's okay. SFML libs directory we can put in here, which I have done. So that's all in. Setting these environment variables will allow Rust, when it's compiling, to be able to find these directories, which it's going to need. So that's what they're for. So we'll set those. Jumped through some hoops so far, haven't we? Not as easy as people might think. Well, it's pretty straightforward in the grand scheme of things, but yeah, a little bit dodgy. Everything below here is severely outdated. Oh, lovely. Thank you for updating things. I mean, if you've bothered to write that... people. I don't know. Oh, wait a minute. Yeah, I want to be here. So now we've got Rust SFML. Well, we've got the basics of Rust SFML and all the backing bits and pieces on our computer, which means we can compile using it. I'm going to keep this open for a minute. Right. Where are we up to? Now I've been through SFML. My God. Why have they made it like that? I don't know. Okay, so we are going to try SFML. There's a little bit of setup required. A little bit more than most people would like. And this is all because the language can't do what we need it to do, and every program will probably need it to do. Set initial goals, set up an expandable project. Here we go. How do you do that? So that's quite interesting in itself. Okay, what I've done is I've set up a Rust Sandbox directory. I want to give this project a name as well. I'm just playing around with something inside that directory, but so don't worry about that. Ignore the fact that there's already a folder there, although I'm going to be dragging some files out of it in a bit. So all I'm going to do for my project is pop a folder in. I'm going to call it Midnight, because that's when I tend to do my best programming, usually around midnight. I'm a bit of an insomniac. Alright, so we've got that. Alright, so it's an empty folder. So what do I mean about an expandable project? Well, in this empty folder, we're going to have multiple sub-projects. Just get you out of the way a second. What I'm going to do is show more options. I don't know why they've done that. Open with code. Here we go. Here's Midnight. I trust. So we've now got an empty directory. I'm doing this because it's just easier to do it this way. So there we go. This is now the Rust Sandbox Midnight directory, which is going to be our project, our SFML application. We haven't even mentioned what our application is going to do, and we probably won't even get to that today, but you never know. I might speed up. Now, I'm going to make two separate parts to our project. Well, not just to demonstrate, but because we're actually going to need them in the future. So, cargo. New. The first thing I want is a library. I want a library that I can build. I'm going to call it Dusk. I don't know how to do a library. I think we just do that. Shall we find out? So all I've done is put cargo new Dusk and then dash lib. Remember, I'm new to this game. There you go. Creating library Dusk package. Ooh, that's nice. There we go. We've got a library or lib.rs. Have a quick look. Look, there you go. It's got garbage in it. Thank you. We really needed some garbage in it. No idea why they've done that, but yeah, that's very, very nice. Thank you. And then the project that we're going to be working in when we're not adding like functionality to our library, well, I'm going to call it Dawn. So cargo, bleh. Cargo new Dawn. Don't need to put anything on it. It'll should just create a binary by default, an application. But hold on a minute. Hold on a minute. We've got a problem. If we try and do anything with this, wait 1 second. The thing also that cargo doesn't do is put in the readmes. Readme.md. I don't know why it doesn't do it. It's just not an automatic feature of Git, which comes with the cargo. Alright. I'm going to put one of them in here. Because I do use them. Okay. On the top, so here's our two lovely, completely, as you can see, cargo tomls. They're both completely independent of each other. But I want to turn this into a workspace so that they're not independent of each other. I want these two to be linked together. We're going to need an extra cargo toml here, aren't we? Yes, we are. So here, in the top directory, I will put a cargo toml. Like that. And because I'm me, this top directory doesn't have Git, so I'm just going to put a readme in a lowercase, and I'm just going to put .text. So there's a readme now for the whole environment. There's a cargo toml now for the whole environment. And we've got we've got a library at dusk. That's got a target in it already. Why has that got a target in it already? I don't know. And we've got Dawn, which is our main RS, which is the one we'll probably be working in, so I'll keep that one open. And you can see that that's not too bad a setup, but this is a bit empty. It's not really saying this is going to be our workspace. How do we set up a workspace? Okay, let's open a file. Because I make notes everywhere. I'll probably put it in the projects. Here we go. So let's try a simple game development sandbox. I've got a list of things I want to try out in it. Okay, setting up a workspace. So in this cargo toml, can't put that. It won't like it. There we go. We're going to say, hey, look, we want to make a workspace. We're going to use resolver level 2. Resolver, a different feature resolver algorithm can be used by specifying a resolver version in cargo toml like this. Package name, my package version equals blah 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 resolver. Version resolver is the original resolver that shipped with cargo. Version 2 resolver introduces changes in features, unification, blah blah blah. The resolver is a global option that affects the entire workspace. The resolver version in dependencies is ignored. Only the value in the top level cargo.toml will be used. It basically tells Rust, hey, this is how the workspace should look, or should be. What you should expect to find type of things, and it sets off the rules in Rust for understanding how this workspace is structured. So we need that line. That's a definite. Now we've got the members, dusk and dawn. As you can see, we have the members, dusk and dawn, where dusk is our library and dawn is our application. And we're working in the directory of midnight. We don't actually change this. Will that work? Shall we find out? So at this point we're at, I think I've got all the files I want. Yeah. Yeah, it's looking okay. You can see that I've got 2 Git repositories now. 2 lots of committing. Each has their own messages. That's okay. That's what I'd expect. So everything's now looking like it should. I expect things to be like this. What happens if I run this? Something interesting happens. I don't want this target. Can I get rid of it? I'm just going to type in cargo clean. Remove 0 files. What has this got in it? An info, a cache, fingerprint build, depths. I don't want any of this. I might just leave it alone. Should we try removing it? We could break everything if we do. That would be funny. I'm going to delete it, see if I can break things. I like breaking things. Because I really don't want it. So I'm removing that. What happens if I run? From here, remember, we've told Rust where everything is, so it should be able to build our binary in Dawn. So, cargo, run, compiling, finished. Hello world! But look where the target is. It's not in dusk, it's not in dawn. Look, it's here. There's our executable. Yeah. So it's actually using the workspace. Won't that cause problems later on? Probably, yeah. So there it is. So we didn't need whatever it was doing in dusk. So we've got dusk till dawn. If anybody knows the reference, well done. Okay, so we've now got the ability to edit, alter two totally different source directories, and when I run, it's going to compile everything. As you can see, it says compiling dusk version 1 or 0.1, and it gives me the details. Compiling dawn gives me the details. Finished, running, hello world. And it's running target debug dawn.exe. So it tells you exactly what it's doing and shows us that this is working. Nice. Don't you think? At this point, I would like to cheat a little, because the next part of setting up the project involves a little bit of typing. So during the week, whilst I was clearing up all my other files and making them more respectable, I created possibly a couple of little files here in Win32 application for us. Alright, under application. Here we go. So we've got main application info, and we've got something in application. Oh, it's a window API. Okay. So what I would like to do is take all of that lot, press copy. This is what I was saying about files being able to be dropped in and out of things. If you have files which you've already written, you can just copy them over, which is exactly what I'm going to do. And then we're going to look at them. So I'm going to go into midnight. We're going to go into dawn, where main is. And I'm just going to paste it all. Replace destination file, please. Thank you. So now we have a few files: main, application info, application, and a subdirectory with a window API in it. If you've seen the kind of way I program before, you'll understand that what I've done is I've made jigsaw pieces, and those jigsaw pieces, well, I tend to keep them small if I can. That way I can handle whatever's on screen at one time. And that's my basic setup done. We're going to look through all of these. They don't do anything, by the way. You see, it's just me typing in notes. So the application info, just notes. The application itself, just notes. The window API, nothing. So there's nothing there. I haven't done anything behind your back. All I've done is typed in some notes, as I wanted to plan out roughly how I wanted to go about this. But now I'm happy. Now I'm happy. I've got a start point. So if you're wondering why there's this question mark here, app.rs, yeah, I wanted really to avoid abbreviations, so I did end up calling it application. Yeah, why not? It's a bit more to type in. But we do now have So in the subdirectory for the app, we really need to do this now. So our application, it's the last stage, which is dawn. We have to open our cargo toml and add a dependency. We can't do this by using cargo, or can we? I don't know of a way, so I'm not going to. I'll entertain the idea, you see? What we're going to do, pop that in there. What this will tell Rust to do is say, hey, we are compiling it, so bloody well use it, or allow us to use it within our application. Okay, that makes sense because we've seen that kind of thing before where we add a crate. Well, this isn't adding a crate, it's adding our own library, which is just next door. That's how you do that. Makes sense. We can then build from the main directory, and that will now add the library code into our application. So we could develop a library. Ooh. Are you excited yet? And there we have the basics. We don't need to be looking at the source code. The basics of what I would call an expandable development environment for an application. We've got the application itself, and we've got a library which we can develop, and we can add more things, more libraries, other things. There are rules that I use in the background for how I will develop in such a thing. For instance, Dusk, I will probably never ever alter this. Dusk will always stay without any dependencies. Anything I place in Dusk, our library, is going to be our own stuff, which we'd probably develop using a dev area first, and then just copy the files over. A bit like, you know, input and output to files, loading and saving them. We've done that development already. Maybe that can go in here. There's foreshadowing for you. So, we're now using our library. Try that. So if we cargo run, compiling, finished, running. Let's have a look in our target. Oh look, we've got dawn, exe, we've got dusk, lib. That's nice, isn't it? It works. I think we're done. Oh, we're not, are we? What haven't I done? The one thing we should always do before starting to save this stuff. Clippy! Ooh, nice. Now we're done. We can now write any application that we want. We have everything that we need available to us, not just to write an application, but to write a library that supports an application, a library which can be transported into other applications. We only need to write the library once, and it can be used by anything else. We just copy it over. So in development, you'll notice that because of the way I've gone about things, we only ever write code once. We can develop it for as long as we want, but we only ever do it once. After that, we just copy and paste. Files, not the code, files, the whole thing. The same with libraries, which is exactly what crates are. Crates are libraries, and all we're doing is copying and pasting. We're using them within our project. So let's do that. And we do have to be a little bit more careful, because we've now got multiple areas in our project. And we're going to work on Dawn a little. Let's get all this. Is this right? Do I want to extend this anymore? Well, we said we're going to use SFML, didn't we? So I'll put that in the base setup as well. So I'm just going to change the directory to Dawn. We can have a look at the directory. Just list it out. There we go. Git ignore, cargo toml, and readme. Looks good. Okay, we're in the right directory. So all I'm just going to do is put in cargo. I would if I could. Cargo add. And we'll have SFML, all in lowercase, wallet. We said we're going to use it, so we may as well. We are now really at the stage where we have the full setup for SFML anyway. It's not an easy one. You might notice audio graphics window, but we've got minuses on SERDI and CI headless. So those aren't being downloaded. That's good. So I'm just waiting for Visual Studio to build its artifacts. Yeah. Procedural macros. Libflaxis. It's doing weird and wonderful things, is our Visual Studio. Good for you. Good for you. So this is what we've added. An auto config, bitwise flags, CC, which is a C compiler, CMake, well, we've downloaded and added that anyway in the background, well, prior, libc, which is one of the main C libraries, libflaxis, no idea, link to C++, so we can access the SFML C++ stuff. Num traits, okay, whatever, the configuration for the package. SFML itself, Schlex, if you say so, and wide string, which is used by operating systems usually. Wide string is a bit different to a normal string. It's got different sizes. Yeah, we'll not go there. A little bit complicated. Yeah, done it. So now we've added SFML. We'll come back out. to our midnight directory, and all I'm going to do is run it because SFML needs to be compiled. It's downloaded it, and I wouldn't want to compile it at this stage, so let's get it compiled, shall we? There we go, didn't take long. Right, so SFML is compiled. Does that alter this? No, it's been implanted within our exe, hasn't it? Okay. Right, let's have a closer look at everything else, shall we? Do we need this big? Not really. Right, let's have a look at main RS. There we go. So our goal, we can fill it in now, is to create a generic application foundation. Ooh, without too many eyes. There you go. That's what we're going to do. We're going to create a generic application foundation. We haven't even decided what our application is going to be at this point. I already know what it's going to be, but that's beside the point. What we can do is make an application that is so generic that it can be used anywhere. Write once, reuse your code. That's the key. Alright, let's have a look at the other files that we've got in here. So we've got an application. Let's go there. In our application, we're going to use create application info. We'll have a look at that next. Holds the main loop for the application. So we're going to do a structure to hold all important data for use in the application, and we're going to implement don't know what this is, but I think that's what it's supposed to say. Implementation of the main application, create and initialize, run the main loop. So yeah, that's a generic application. Okay, it's not so bad so far. What's this info business all about? Well, this is where we can put public enums types, and hit this is all going to be for access by the application. I've given an example like constants, window title, window width, window height. That's just an example. Enums describe the available application states. Is it starting up? Is it in the main state? Is it showing? Is it in a menu state? That kind of thing. We're going to put all of this in here. And we can use a vector as a stack for holding the application's current and previous states. We'll go into that in more detail later, but that is a generic way of using application states, or a state machine, as some people might call it. We might be using a state machine, so I'm just hedging my bets with this last bit. So that's those two. Under application, I've got a window API. Bit empty. What's that going to be? Well, that's going to be accessing the window. So that's what APIs do. They access things. See, it's a programming interface, application program interface. So we're going to be writing our own. This is probably going to hook into SFML. So this is where our SFML code's going to go, most likely. Possibly. Don't know yet. We haven't written it. Everything runs, yeah. Everything's okay there. And I hate the fact that Visual Studio has done this. I'll just clear screen. Just making sure that I haven't messed things up. So all I've done is put notes together to help. You might know that I do this a lot. I don't program in a programming language. What I do is I program in English, and then I get the programming language to do the things that I want it to do. I find that programming in English is usually a better idea. Yeah, I can get my thoughts straight. That helps me down the road. So we need main RS. That's okay. Right, let's get all this lot saved. So, base setup. That's all it is. There's nothing much going on here. Okay, that's you done. Why didn't it do it? It did. Alright, just moves that. Base setup. Have to do it twice because we've got two separate things. There we go, everything's now happily hunky-dory saved out. And you notice that we've got two gits, one for dusk and one for dawn. Very, very nice. And now we have a setup. I want you there. I'll have you there. We'll put the window API up as well. But you never know. You never know. So I've got all my files now that I've put in. There is nothing in there, is there? Right, okay. Right. We've got our goal. And I've done my notes. I prepared my notes. Did I do any research? Okay. Let's go to the examples. Do we have a basic window? OpenGL. We don't even have a basic window. Ba 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 boom. Got Pong. We might refer back to that, but I want to do something slightly different. What's this tests thing? Oh, right. Just tests different things. Alright, okay, we can use this as a reference. It does show us how to create a window. With window config though. Eek, no thanks. That shows us nothing. Just looking through the examples, see if there's anything straightforward. We're not going to use that. I'm going to SFML. So sfmldev.org. So it's in C++, C, .NET. Wow. Learn. Tutorials. Oh, yes, please. Windows. Window module. Open and managing an SFML window. Ooh. We might need that. have we got a decent piece of code in here? Events explain, blah blah blah. Okay. Da 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 da. Oh yeah, building SFML from source. A lot of people will say when you're using a library you should build it yourself so it doesn't go wrong on your machine. I disagree. I don't think you should build your own. I think you should use whatever you're given. That way, if it does go wrong, you know what kind of experience to expect if you transport it to another machine. Otherwise, if you distribute your code, people who want to build it will have problems because the SFML will be built on your machine, which is different to theirs. Is there not a getting started thing? Let's have a look. Network. Oh, there's a network module. How lovely. Oops. Reference frequently, yeah, blah blah blah. Where's all the nice things that this thing can do? 2.5.1 tutorials, API documentation. I know what I'm going to do. I'm going to go to GitHub. SFML. All I'm looking for is one of those lovely sample things. Examples. There we go. Window CPP. There you go. That's what we're looking for. It's got a load of garbage in it, which we for OpenGL, but hey ho. Fine. Right, let's. There we go. So this gives us an idea of what the commands look like. It's got a video mode on it. Context settings. Oh, I might not want to use that. Win32. Oh my god. Didn't know they'd done this. I'll look at that separately. Alright, looks like we're going to have to make this up ourselves. That's a damn shame. Okay. So, create an initialized application. So, we're looking at application. Alright. We can use the crate. Yeah. Holds the main loop for the application. Yeah, and we'll also need a structure. Now, I've already mentioned that I want to... Hello, we've got people in chat. Why SFML? Why not? Give me the other options, please. I'll answer your question. What are you looking for? I was looking for a bit of sample code which would be nice and handy for reference, but I'm not really bothered about it. We can probably make this up ourselves. So, first things first, I'm going to make a structure, I guess. And I was talking about abbreviations, and I'm going to use one. So we're going to make a public structure. Yeah. And we're going to call it app. You can blame Qt for this, not me. We're not going to put anything in it. Not yet, because I don't know what to put in it yet. Are you looking for a windowing library GUI toolkit? Nah, not really. SFML is just a very nice, basic multimedia library. The GUI and stuff I will adventure into later, even in ECS. But I'll add those separately. SFML you can add to quite happily. It doesn't rock the boat too much. It's one of those kind of... It's a bit like SDL. You can mix and match, mess around a bit. So I'm looking for generic kind of crates, really, that you can mix and match and do what you want with. It should work, I hope. If it doesn't work, as you're going to see, we're going to be designing this in such a way that we can just rip it out, throw it away, and put something else in. If you want a generic app, how are you going to do a multi-plat window? Well, SFML is multi-plat. It's multiple platform. Works on any system. It works on Windows, MinGW and Mac OS. So it's on screen. Platform support. So you'll be able to take the code that I'm using, put it on any platform and compile it. There you go. So what do we need here? Public, I guess. Implementation. Maybe not. Let's just go for implementation. And of app. Do we need this public or not? You never know with this game. There we go. No, we don't. That solves that question. And we're going to place in here our default, well no it's not a default, our construction for a new app. So this is going to be called new. It's going to be a function. And we're going to call it new. Why not? There we go. Done. So if you do write a generic app, you're quite right. You should really put in the back of your mind, hey, I want this to work on any kind of machine or any operating system. SFML covers out those kind of things. SDL does. Trying to think of any popular ones. After that we start getting a bit fuzzy. Those are the two main ones. It's just size of library after that. SDL is bigger. It's a larger library. It does more. Do you trust them? No, I don't trust them either. But anyway, that's slightly different, isn't it? That's got to return a self. So that needs to return the app. So we'll do that. That means all we need to put in here is app. There you go. We've written our first code. Awesome, isn't it? That easy. we now have an application. So this goes, let's get our notes straightened up. So that's implementation of main app. So we can put that here. Create and initialize. That goes in here. Run the main loop. Alright, I think we can do that as well. So that can go in here. This is all in the implementation of our app. So let's do a public function. Run. I'm not going to do anything with it at this point. There we go. So this is like a standard setup for how we can use an application. You might notice we haven't used SFML. This is just basic Rust. Nothing special going on. Mod application info. Do I really need application info in here? Yes, I do. There's a reason for this. When I was thinking about the design choice, if I put mod application inside of application here, it'll put it in a subdirectory. I'll put it into this application subdirectory. So this file would move into that subdirectory. And I didn't want it to. I wanted it on the top level of the crate, or our development. So I intentionally placed it here. That could come back to bite us, couldn't it? So we can create and initialize an application. So let's application equal it's going to be application app new. There we go. That gives us an app. We can now run the application. So take our application and we can now dot. No, we can't. So that's not working. Did I do something wrong? Probably. So we really require a way of getting that application to run. Yeah, I can see a problem with that. I wonder if I change. I'm going to do something which I don't normally do. I'm going to put the U in there. Which it doesn't like. Oh, that's the mod done by me. So we're going to use application, app. Try that. See what happens. I think I know what's happened. Did I use copy and paste? I did somewhere. I'm not sure we really need this. I don't think we do, but that's got nothing to do with it. Why is app not responding the way I think? There it is. That's not what I want to do. Public function, yeah. Huh. How interesting. This drives me a little bit insane. What's this say? Implement some functionality for a type. Yeah, I know. All right. For some reason, I'm going mental. We've got an app. Why can I not use its functionality? Are we sure this isn't supposed to be public? Remove the qualifier. Yeah, okay. And this is where my experience with Rust runs a little low. Literally a little low. Just gonna have a quick look at one of my projects because I'm not certain why it's doing this. It's not responding the way I expect it to. Yeah, it's just dot run. I know what I haven't done. There's your answer. Okay. I didn't complete the function signature. Okay. May as well put this in just there. Application is running. We may as well have some output. There you go. Yeah, I'd forgotten that. You see, you forget little bits and pieces, and yeah, it will cock up your program. Here, I'm just going to put in... These don't stay. A new application is being created. We'll pop that in as well. Could do with a bit of spacing going on here, but I'm not that bothered. Alright. Yeah, yellow squigglies don't bother me. It's red squigglies or things that I can't actually do that bother me. Right, so we're okay there. Let's go back to main. Now this should give me an application dot run. It does. We've got red squigglies. Cannot mutate immutable variable application. Quick fix. Make mutable. Now it should work. There you go. That's it. The last part is exit the application. That happens when we hit that. That's fine. And that's our main function, or our main functionality. Massive, isn't it? Back on our application, we've just got 2 printouts. Nothing going on, really. Check that we've done it right. Yeah. Okay. A new application is being created, application is running, and then it just exits because, yeah. So we need to correct that. Our notes. So what I'm going to do, exit the application. We're just going to put in print line. And here we go. The application has shut down. We call it shut down. I don't like the word shut down. Yeah, it'll do. I'm not that bothered. It gets deleted, so. So we've now got a generic application foundation. Or have we? Well, no, because nothing's happening. We don't have a main loop. So that's the area that we need to look at. We need to create a window. Well, I think we can create a window in here. So let's probably do that. Yeah, alright, we can do that. In here we're going to need a main loop, aren't we? So let's do that. I do most of my programming in English, sorry about this, but it's just, I find it easier. So main application loop. I'll have one of those. I always mark them main loops with brackets, which you're allowed to do. What do we want to do in our main loop? Well, we need to poll the OS operating system events. In other words, talk to your operating system, say, hey, has the keyboard been used? Has the mouse been used? All that kind of good stuff. Yeah, all that kind of good stuff. We need to update our application. Run all the systems, update the application state. Quite a lot of stuff really goes in there. And then we can display, well, we call it render, don't we? So let's call it render. Render graphics. Graphics is a bad word. Render to window. Anything else we need to do? Oh yeah. The exit of the loop. Do we want a shutdown? I don't know. We might. So I'm going to put it in. There we go, just program the main loop. I think, have I forgotten anything? Because we're at the stage of pseudocoding. Just trying to get things in the right order. I'd like to do the main loop. But we can't. We have to do everything at once in this file. That's awkward. Just checking to see what information I got on there. I think we need to create a window. This is the last time we can run our program. So, yeah, we know what it does. It does that. Nothing exciting at this stage. Now, before I start messing things up, we're going to save this out. So, what changes to done? Here we go. Begin development of our main window. I think that's the best way of putting it. Yeah. We've got enough notes in. And it's looking okay. So we need to fill in all of this up to here. How do you want to create a window? We could use the window API. Yeah, there's nothing here. So we'd need a public function. Let's just say create window. Yeah, I always try and use different files wherever possible so that I can focus down on what I want to do. Really, That's the best way of putting it. This has to return something, a window. And it's probably going to be a window handle, isn't it? Let's... some kind of window handle. Yeah, we'll just put that for now because I don't know. We're going to use SFML to create our window. So SFML, window. Ba, 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 ba. Module window. Clipboard, joystick, mouse, sensor touch. Oh, thank you. What about new? OpenGL based windows and abstractions for events and input handling. Great. Are you going to tell us how to use you? Here we go. Found it. Struct window. SFML : window. Okay. Do we have that? We do. SFML window. Okay. Do that. That sounds okay. Public struct window. New. That sounds good. That already tells me we've got an SF result fbox self. Right. We'll get to that. No examples. That's useful. Okay. So what we have here is something like a window. I'm going to let... I need some more information about this. So we're going to let win equal window. What about new? No. I got a feeling that's a window with a capital. Yes, it is. There we go. We've got this result fbox window and an error. So we know there's some error handling to do. So we'll get rid of that. I'm just going to cheat and use expect. We'll stick an error in there. There we go. What can we do with that? It's an fbox window. New. Is not a create. Open. Open from handle. System polyvent. Yeah, we'll need that in a bit. Wait. Set icon. Close. Open. Is open. We need that. Settings. Set title. Set visible. Mouses. God knows what. Active. Display. Blah de blah. Not overly... It's not telling us what we really need to know, is it? Create a new closed window. How can you do that? Creates a new window and opens it with a specified... Oh. Video mode, title, style and settings. Alright, I think new open might be better. It's got these goddamn brackets. There's simpler ways of doing this. Are you going to show the window when creating or on run? I don't think there's a reason for me to hide the window until the run section. I've already played around with this in Rust project. So we're going to cheat. Oh, I've used render window. Ah, get out of it. That's where we're going wrong. Huh. What does render window use? Render window. Ah, so there's different types of windowing going on here. I'll keep the expect bit. Self window. Oh, right, okay. That's interesting. Let's have a render window. Do we have one here? So it's going to be the window. No, it's graphics, isn't it? Yeah. It's here. Yeah, so if you look under window, you come to here. Huh. That's good, isn't it? But if we look under graphics, we come to here. Huh. That's interesting, don't you think? So it's in a completely different module. Exactly the same thing. Oh, it does have examples. That's kind of it. So we need render window new. This is possibly what we would like. Now you know why I prefer to have things that are useful lying around on my hard drive. Okay. So we can use brackets. For that, that's the mode. We can have a title. Okay. We can have a style. Default, please. How's about that? What else do we need here? Why can't I see it? Ah, there we go. And default. Well, that doesn't help me much. Style settings. Context settings. We'll just have the default context settings on. Alright. So it's and default colon default. There you go. Yeah. Don't care what I put in there for a minute or two. Do they put the expect on? No, they put a little question mark. That's fine. Set the vertical sync enabled. Okay. I think we want to do that. So it's just going to be win dot set vertical sync. No, I'll have the frame rate limit, thanks. 60. And we need to reply there. Okay. Expect message failed. Ah, yeah, good point. Thank you. So this is an Fbox render window. Pretty cute, isn't it? The way this all comes together. So let's pop you there. An Fbox render window. Somehow that doesn't really seem to work. Let's try putting that in properly. Fbox. Well, no, we don't have an Fbox. So we've got SFML CPP Fbox, yeah. Alright, we'll just import that a second. Doesn't like window, because it's not mutable. Okay. Seem to have got somewhere. I think we'll keep this going. We've got the event loop here. Oh, I like this. This is a straightforward thing. Okay, we'll use this. That's how we create a window. But there's some problems with it. Magic numbers. A title. Things like that. Why are we using so much here? I'm a little bit dubious about this use thingy. No, I'm going to leave it. I'm going to leave it as is. I'm thinking about getting rid of some of this. But yeah. There's always that in the back of my mind. How these use cases and things like that. Never usually over happy with them. I'm never usually happy with this kind of idea, but I've got to get used to it, so let's leave it alone. That tells what I'm using. Okay. I'm doing 60 frames per second. maximum. That's because the screen I use is 60 frames per second. You can put whatever you like in there. Not really. This is where our info comes in. What I'd like to do is use these. So public const max FPS. Don't know. U32, thank you. U32. I never assume. We're just going to put that to 60. Why am I doing this? Why on earth would you have a file like this? Simple answer is it collects information about our application, and that information may change, and we can then find all of that information in one file. So if we want to change whatever this window API is doing, we can change this. So that's 1080p, by the way. So if I wanted to go up to 4K, just change these two numbers. If I wanted to use a different monitor, I just change this number. I don't have to dig around in my application to find the code anymore. So we're going to have to use application info. So we can use crate. Is it with a capital C? Don't know. No, it isn't. Okay, crate. And we'll go with the info. And now, oh, it's done all of this stuff in one line. Can you separate those lines out? You won't do it for me. Thanks. Alright, I'll want it like that. So here, I should be able to put in width. Now you know why I didn't care what I put in there. Height, X and Y. Here, I should be able to put in title. Here, I should be able to put in max FPS. Alright, I don't want this. That looks awful. I'm just going to put an asterisk there. For now. That's what I would prefer to be seeing. But now we can create a window. Notice that I'm not sending anything in. That's bad. So this really isn't in the right place, is it? What would happen if we were to say width? U32. Height. Why am I doing this, you're thinking? U32. Well, what is the title, please? It's an and string. Okay. And title. Application info does not belong inside of Window API. Application info and the use of that belongs inside of the application. Yeah. And it's pretty damned obvious when you think about it. What are we going to do about this frame limit? Which is U32. I'm going to put that in as well, I think. Comma. Frame limit. FPS. People understand FPS better, don't they? Stuff it, we'll just use it that way. Max underscore FPS. I think that's the easiest way of putting it. U32. We can pop you in just here. Looks a little bit more different. This is now not used. We can transport that out of here now and put it in application. Yeah. So when we call our Window API, we're going to put the information in our call to this, rather than messing up our Window API, which is full of SFML, with our own stuff, which isn't full of SFML. So to create a window, we'll call it an application window. We would need to use our Window API. Okay, so it will be our Window API. Create window, and as you can see, it comes up with everything. So our width. Oh, I don't like the way it does this. The editor is going to be a window width. The height is going to be a window height. By moving it, it matters in the long run. It just looks a bit weird initially. Max FPS. that creates a window. And we're not using SFML. And it's doing more than a single operation, because we've actually got the FPS in there, which we need. We do now have an app window, and I've put it in new. Okay. So this window. Now I've got a problem. We've got an F box. We didn't send a pointer back, did we? Please tell me I didn't. F box. It is a pointer. We're sending back ownership. Yes, we are. We can't unwrap that and just take render window out, can we? No. Okay. So we are going to have SFML in here. Okay. And it's going to have to be one of these, which is an F box. And it's going to be a render window. And as you can see, it's already come up. Ah. Okay, we'll accept that. We now need to fill this in, which is app window. Like that. That's looking okay, isn't it? You're probably thinking, why not just put this here? I'm looking, because there's, you might notice, yeah, error handling. There isn't any here. And I think that should be a comma. Like that. Anything else we can change? I think, am I happy with that? I am. It feels clean. But it also tells me exactly what's going on. That we're creating a window with a window width, a window height, a window title, and a max FPS. The code that we've written tells us exactly what it's doing. Yeah, we're getting an F box. Yeah, so we're dependent on SML, yeah. That's okay. I was hoping not to be. I really was hoping not to be. So, we need to get as far as polling the OS events before we can run this. There's no way we can do it without this because of the event close thing. Otherwise we can't close the window. That would be embarrassing, wouldn't it? So we've got a self. That refers now to our application storing a window. Nice. Let's have a look at this main loop. While let some event. No, thank you. All right. I think what we'll have is a while loop. So while self, we can access our window, is open. So while the window is open, self is coming through from here, our app. If you're wondering what this self business, it just refers to itself. Itself being an implementation of app, and an app being this structure. So self, you've probably come across it before. So that makes sense when we write it. Excellent. Now we have to do the poll events. So I'm just going to do whatever they tell us to here. Probably not the right code, but it'll do for a second. Okay. I don't want to do that. But to get it going, I think we will. We know that that's not right. That's self.window. There we go. Event comes up now. That's nice. Some event. And there we go. We can match the events. Lovely. That's always nice. Event : closed. Not sure about what they've placed here, so I'm going to have a look at what I do on this. No, got to do it that way. Do we have an event? We have an input. Alright, that's what I've used. I've used event closed, yeah. That is now self. Okay. Non-exhaustive patterns, of course. So we need the underscore, don't we? So default. We always need a default. Okay, we don't like this. Okay. Would that work? So while the window is open, we do the loop. As soon as the event comes through to close the window, close the window. Update application, don't need to. Render to window, don't need to. And shut down, well, don't know. Is that the simplest I can do? It's doing weird things up here. Yeah, okay. I'll tidy that up later. So yeah, we should have what is possibly a straightforward thingy. Does it work? Okay. Try if event equals closed. Consider using if. Yeah. I know. I agree with it totally. That's actually quite funny. Process didn't exit successfully. Target debug dawn.exe. Status DLL not found. Which DLL, please? That's damned useful. It doesn't tell me which DLL. So something's not quite right, is it? I did do it from midnight, didn't I? Yeah. Does anybody know? Well, what did we change? Well, we changed these, didn't we? It looks like we're having a problem with our DLLs. That's interesting. Why would we have problems with DLLs? Well, simple answer is we are compiling this dynamically. Let me explain. If we have a look at the library here, SFML 251, we included the include and the lib, but when you look in here, there's a load of DLLs. It's got no idea about them. When you look in the binary, we have all the dynamically linked libraries, DLL. And we're linking dynamically, and we have no access to them. Fair enough. Do we know which ones we need? No, not really. Am I going to look it up? No, not really. If we take a copy of those, go to our Sandbox here at midnight, and we go into our target directory, debug, and paste that lot, there's all your DLLs. It works. And that button should work. Thank you. Interesting, huh? Now, the reason I didn't look that up is because I don't care. This is a sandbox. If I was doing a fully fledged application, then yes, I would care. I'd care a lot more than I am doing right now. But I never do it that way round. I always do a sandbox first. So we now have our first window. Didn't take too much code. It's not very good code. In fact, it's awful code. But it's our first window, so we'll have it. And that's everything really for a base application. Let's develop this, shall we? We're in a sandbox, and that's awful. Alright, I don't want this in here at all. So this doesn't belong here. I know it doesn't belong here because this is the main loop. And this is gonna grow. It's gonna grow. There are quite a few keys on your keyboard. If we start detecting every single key here, can you see what's going to happen? There is quite a lot of functionality on a mouse. Yeah, we're going to have to detect all the events for a mouse here, aren't we? It's going to grow. And we're going to have an application file full of event handling. We don't want that at all, ever. Like, we don't want it full of creating a window. There's going to be other things added here, obviously. So let's sort that out. That's no good to me whatsoever. An easy way of doing that is probably create a module. What should we call the module? How about input? Because that's what we're looking at. Application input RS. Where do we want it to go? Well, it's not. Is it part of the window API? It is, really. Polling events. We could call it event API. This is where we can get a bit vague. We can attach it here, or we can attach it here. Which is the correct answer? Huh. You like input, yeah. That's good. I think we're going to use it as input. What I'm looking at is application already. If we put it in there, that's going to take a subdirectory. We'll be accessing it from here. We won't necessarily be accessing it from the window API. I'm going to put it here. So it comes up here, window API next to input. For now, we can move it. I don't think that's necessarily a problem. And what we want to write will be something like input events. Yeah. Did it put it up for me? No. Thank you. We'll pop it in here. Don't know what I'm going to be using, but we're going to be using a public function. And it's under input. So we can just call it input events. I don't know. Call it anything for now. Change that later. Okay. It's gonna have to take in something. Does it have to give back something? Yes. So there is going to be something here, which is another one of these result type things. I have no idea what it's going to be. Okay. It's inside a loop, so I can't print a line, otherwise it's going to spam me. And it is here that we'll want this. And it's going to have to give some kind of reply. Do we want this to be able to close a window? No. So that has to go. We can't have this. We can't have it doing that, because then the application will have lost control of the window. And the application has to control the window, because it's its window. It doesn't belong to the input system. We are going to be needing to use the window to poll the events. So we can probably get away with leaving it there for now. But that does create a to-do. This file should never close the window. It's not this file's job. This file's job is to deal with events. So we're going to have to alter that. We will need the window. So is it mutatable? No idea. It's going to be an application. So we are going to need an app. We'll need a reference to it, because I don't want to be sending the whole goddamn thing through. So we'll need an app. We're going to call it main app for now. Like that. Which means we can now do that and that. We don't have an app. We'll fix that by importing it. What's this now? Oh, it's just plonked in the middle. Okay. We don't have event, so we can fix that. Okay, and it's not liking this. Cannot borrow main app as mutable. So I'll mutate it. Okay. Yeah, definitely mute the app, because we are going to be changing things. Well, that is a change to it at the moment. All right, that was successful. So what we really need to do is just say, hey, let's use this. We have use nothing. Okay. So we're going to use input. That's for sure. It doesn't like that. Okay. Syntax error. Expected identifier. You want self? Okay. All right. Oh, look, we don't need you anymore. I'm happier. You can see what's happening. So, input events. We can now use that. Don't like using it like this, though. Alright. Whatever. Yeah, because it's coming up like that. Main application will be self. Yeah? So we've now removed the event system into its own separate area, so we can look at that and focus on that individually. This use thing is still bothering me. I'm going to think about that over the next couple of days and see if we can change that. Alright. Bit tidier. I'm just going to pop a clip in, because I know that I'm making a mess. And we're still only coming up with that one, are we? Yeah, it looks like it. Okay. Application is running. The application has shut down. Nice. So that's how you can move something away from... This is a control flow. This is your application's control flow. We don't want functionality here at all. There's a little bit of functionality, but it's all to do with controlling the flow of the application. This is not really what the application is. The application will be defined by the update, render, and input. So we've now got an input system. it's going to have to return a result. Of some kind. Or it's going to have to do something. It's going to have to call other things. That's going to be interesting. Probably systems. Super. What does super mean? It means go up one directory level. So as we can see, our input is here. It has to go up to the previous directory, which is the application, so that it can use app in application here, which is a directory above. That's what it means. We don't need that much space. You might notice I'm not putting notes in. I will do, just not at this stage. I've got to do though. I think that works okay. Can we clean that up any better? We could try using this key pressed thingy. I mean, that would give us the same difficulties, and I don't like the way they've done it with the logical OR. But I want to look at it anyway. So what we're looking at here is event key pressed. Yikes. What the hell has it filled all that lot in for? Thanks, game. So, code colon is key escape. Yeah, key escape will do. Yeah, key. This gives us an idea of how we can use this in future. So I'm doing this because it's in the example, really. Why is key escape not here? Because key isn't here. Heh, probably. Okay. Scan Alt Bool Control Shift. Yeah, okay. Can we just get rid of that lot? Thanks. I've got a feeling we can do this on one line. Yeah, probably. Because that's really going to be doing something along the lines of that, isn't it? Yeah. We've got that again. We've also got a comma here. Not sure about that comma. We'll come back to that. Okay, so it is commas, isn't it? I think it is. Missing structure field. Scan Alt Control Shift System. Pattern does not match. I agree. Just going to refer back to this. Oh, it's got to have that stupid ... thing. Alright. Okay, quick fix. Import window keys. Yeah, I thought you would want to do that somehow. We can separate this down, but I'm not going to at this stage. Again, tidying up the code later would be a good idea. So now if we run this and press the escape key pressing now, the application shut down. So that gives us key presses. So we now know roughly how we can detect key presses. This dot thingy, this allows us to detect the escape key with the control key being placed down, the shift escape, control escape, alt escape. So that gives us all the combinations. And then there is a public system bool at the end, which I'm not certain about, so I'm not going to say what that does. I think that's fair enough. Might have to look that up. Oh, is that the Windows key? The system key? I think it is. There you go, just had an idea of what that means. Don't quote me on it, didn't check. So we now have a fully functional event system for input that is looking as though it's going to be pretty damn useful. Expandable. Alright, we've now got an input system. So, how can we define that? So, input events. Okay, that'll do. That describes that. We're not done badly, have we, really, so far? This application doesn't do anything, obviously. There is something that I would like to do. I would like to render. Now we've learnt that this is probably a better way to go. We'll be looking at render everything. I mean, I'm being very lazy on how I'm programming this, by the way, by using self. Yeah. Let's create a renderer. So we can have a module for rendering. Where would rendering light go? Oh, we'll pop it here for now. So we'll do a render. We want to do a nice simple renderer, please. Nothing complicated. We've done input. We've done Windows API. Do we need this for anything? Well, no. Okay. There's our renderer. Isn't it a nice renderer? Now for this one I am going to do a bit of copy and paste. Because I've done it before. And it's not as straightforward as it may look. So I have done a render. Just going to copy that out. My apologies for doing it this way. You know that I don't like doing that. But I want to get this done today. I don't want me to be messing around. It's due to this colour thing. I want these values. and it would take me about 20 minutes to work out what those values are. So I've got that in here. That's never going to work. Okay, that's fine. So we'll pop that. Draw to we don't need that bit yet. We're not that far down the road, so we'll just use that bit. Don't really want that. We just want our app, and we are doing it slightly differently. Okay. It's not a game. This is our main app. So we're going to clear the window. We're using window, so we can clear it using the background color, which I'm creating here as a local constant. And then we, of course, we display the window, which we'll go through that. Okay, app doesn't work, so quick fix, import, thank you. Done, done. Bam, bam. Let's use it. So, we don't really need that use. I don't like that. I just don't like that. We're not using it. Sorry, I'm doing it differently. I'm going to put it here instead. There you go. I don't see why we should put use in when it's not really going to cause us any problems. So render is a module, render all, and main app is self. There we go. So now it's going to render all, and it's going to clear our window to the background color, which is this lovely thing I've invented. We don't have any objects in our program at the moment that we're going to be drawing, but there is a space here for that. And then our main app is going to do a window display. Now this display on screen what has been rendered to the window so far. What it does is it swaps two buffers. So when we are drawing to what they call the back buffer, which is an area of the screen we can't see. When we have finished drawing, we swap the two buffers so we can see what we have drawn. So the front buffer goes to the back buffer comes to the front, and we see what we've drawn. Yeah, it is as simple as that. But now when we run, oh look, our window's changed colour. It's no longer that bright white gleamy globule of mess that I didn't want. We're finished. Ish. Sort of. There's a lot of cleaning up to do here. But we have actually finished. And yeah, by putting that in, we don't need a use case. Interesting. Do we need crate here for application info? I don't think we do. Quick fix. It does say we need it. That's interesting. I get you. Let's just try that out and see how many errors we get. Yeah, I thought that was going to happen. Okay, mess around with that. That's what I do. I like messing around with these things. Seeing what is allowed, what isn't allowed. Why have you put that in? Okay. Not sure why it puts it all on one line, but it does. That's awkward. Alright. I'm not arguing. That's what you want to do, Rust. You do it. You do you. But we now have a program with input, rendering, which I put in the wrong place. Does help if we got put that in. Update our application. I'm gonna put some brackets here. ECS maybe? That's your application functionality. So maybe an ECS here. GUI, graphical user interface. Just getting ideas together of what we can do. How much do we want to do? I didn't check the title. Yeah, it just says application. Good. Right. I think really all this needs now is a cleanup. This is how I would set up a project. And you're probably thinking at this point, my God, look at all the files you've got. It doesn't do anything. Yeah, it's an expandable project. It's not code. It's not just somebody coding and doing this. What we've done is we've changed whatever this is, this little example is here, into something that can be developed into a full-blown application. And we're doing it by being able to focus on our little jigsaw pieces, like input, render, the window API. These are jigsaw pieces, and they, when you put them all together, it forms the completed jigsaw, the big picture, the application. And this file controls access to those pieces. At the moment it's not very big and I don't like what it's doing with some of these things, but yeah, okay. I think we can fix that later. I still don't know why height is there and it's not being told anywhere else. That's a little bit weird, but I've got a feeling that that's Visual Studio Code messing up more than anything else. Weird. Very, 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 very weird. The systems don't seem to be able to work properly. So, is it on the Rust Analyzer that it's doing this? Just do a reload the workspace. No. Okay. Whatever. The only other thing I would like to show at this point is in main RS, I always have a welcome message. Maybe this isn't the right place for a welcome message. I was thinking of putting that into the library to show how you can use the library. Is it worth doing at this stage? I don't think so. I think we're okay with that. Have we met our goal to create a generic application foundation? Have we? Set up an expandable project. Yeah, we did that. Set the initial goals. Yeah, we did that. We can try SFML. Yeah, we're doing that. Implement a structured approach. Yeah, we've done that. Split it all down into our little jigsaw pieces. We don't know at this stage whether our jigsaw pieces are in the right place. We may need to move them around a little bit. We have done that, so that can go. Holds the main loop for the, yeah, that just describes what the file does. Yeah. Yeah. Initialize, create window. Yeah. Okay. Don't think I'm going to argue with this. This looks good. That's clean. It's clean code. Alright. Anything else I want to change in here? That's pretty obvious what it is. Clear. You see, that clears the back buffer. Yeah, this isn't too clear, is it? Clear the back window. I'm just going to call it back buffer. Yep. Here we can put in swap the completed back buffer to the front. I mean, that makes more sense to my mind. I don't know if it makes any sense to people who are going to read it in the future, including me. But I think I do want some kind of explanation in there. I don't put notes on things that are obvious, like background colour. Maybe... yeah. Okay. RGBA. A is alpha, how much you can see through it. 255 is the maximum value, so which means it's solid and cannot be seen through. R is red, G is green, B is blue, and the values are from 0 to 255, which is an 8-bit integer. No, unsigned integer, I think. Are these integers? No, U8s. Okay. So I was right. Unsigned. Pretty simple to set up an application, you may think. And I agree, it is. There really isn't a lot of code involved. The thought went into how to split it down, how to remove the complexity because what you can see on screen isn't very complex. If all of this code was in here, yeah, then this code starts to become a little bit more complex. If you then add in the input events code, it starts getting a bit more messy and a bit more complex. Look on the left hand side. Would you like to be looking at something like this or something like this? Which one is easier to read? Which one is easier to get to grips with? And that's what you got to decide for yourself. I can't decide that for you. What kind of time are we on? Yes, we're right. Oh God, I measured the timings quite right on this as well. Oh God. Anything else that I've missed that I think we should include at this point? We've got our main RS, our app RS, and our app info. And hopefully I've explained why I've popped in an app info. It's going to become more prominent as we go into the state control of the application, which is still going to be generic, by the way. But that's the next process that we want to look at. So we've really done all of this. And I think the next stage is to look at the state machine. Yeah. So I got rid of that lot. I'm happy with the way it looks. You might notice it's not an exact representation of what I've done before. This is slightly different. As when I first looked at SFML, I learnt a few things about it which, yeah, slightly different. No, really, I just want you to handle things slightly different when I went through it this time. As ever, I've not written this in Rust yet, or prepared me thoughts on it, so I don't really want to do it today. Yeah, the state machine. I think that's what we should do next. Gain control of our application. Currently we have no control. We have a little with our input events. We can close the window, but that's all we can do. We can't control the flow, and flow control is your main battle. Once you've done that, everything else is simplistic. All you do is you make a file and you write some code in it and then pop that in to your application. I think that's probably been understood by the way I've done this. But there we go. Our whole application is what? 1, 2, 3 lines of code. Does other things, obviously. Yep, I like that. That'll do, mate. What did we do last? Render. Okay. The first render. All. Yeah, we'll do that. That's fine. So we've done the setup. We've done the beginnings of our development. We've got our first window. We've got the inputs and our first render systems. Well, I don't think the systems, but ideas at this stage. And I think that's a better way of putting it. They're not systems yet. Will we use ECS? Will we use GUIs? Probably. At some point. But at this stage we start needing to think about application states. That's this bit. We also need to start thinking about what our application is going to be. What kind of application states are we going to need? What would be the default state? What would be its running state? Currently, its running state is that the window is open. That's our current running state. I prefer that to say is running rather than window is open, because that is more explicit. Yeah, we'll change that to is running probably. Okay. It's not hard to do, but it is a bit weird. Because that just tells me that the window is open. Doesn't mean that the application's running. You know what I mean? If I'm reading the code, I prefer it to say what it is actually doing rather than give me that. Yeah, that's me being picky. Alright, I think we're done. So we can change these at any time and our application will change. Okay, that's fine. And it's just a couple of lines of code. That's fine. Alright. State machine is for the GUI or for the model beneath. Yeah, you could say that. Well, there is no such separation. When you display your main menu, do you want your application to continue running, or do you want it to pause? There's the question. We're going to be doing a game. So if the main menu is being displayed, I want the game to pause. I don't want it to continue playing because you don't have control of the game. So we're going to have a pause game. Now we can do that using the workflow in application by knowing what state the application is in. Is it playing the game or is it displaying a main menu? And that's why I'm leaning towards a state machine, because they make it very easy to handle. In other words, whilst we're going through that while loop, while the window is open currently, we can ask and say, hey, are we displaying the main menu? Because if we are, we don't want to go and render or we need more information in the renderer to say, hey, don't render the game, render the main menu. We need more information to say, hey, don't update the systems that are playing the game, just update the systems that to display the main menu. And when the game's running, we don't need to update the systems that control the main menu because we're not using it. That kind of thing. Yeah, it's it's more than that, because if you want to save the game out, you don't want to be running the game whilst you're saving it, because that would change the data that you're saving. So you want to switch things on and off. A state machine is the ability to flick a switch on and off. It's binary. And you can have multiple states in an application that do different things. In a role-playing game, you might go from the main world into a shop. And the functionality in the shop is completely different to the functionality in the main world where you want to be moving around. The functionality in a shop is where you want to be buying and selling equipment. Well, the main world doesn't have to be running whilst you're buying and selling equipment. Really? It can still run if you want it to update, but it doesn't have to, because it's never going to interact with the player at that point. When you're in combat, do you go to a separate combat system? I think Final Fantasy is classic for that. If you look at Final Fantasy, you go out of the main world and into a combat screen. Well, the main world isn't being updated, just the combat, and it's a combat system that's individual from the main world and runs separately. But you don't run them in tandem, as it were. Those are design choices, and we'll see. We'll see what kind of design choices we come up against and how we alter the workflow and what kind of state machine we develop. And there's lots of things you can do with a state machine. It opens up the way you can develop your application and make your choices, and stops you from wasting computing time on things that you don't really need to be doing. And you can focus your computing time into the areas that you are actually using at that point in time. One of the things I noticed from last week's development was there is a fault in that development, one that I've been thinking about this last week, and I thought, yeah, I'm going to leave that fault there because it's crucial to the way it operates, and it also calls into question what you should develop and what you shouldn't develop. So that's going to rear its ugly head at some point. There's lots of things where decisions are made, like today, and I've said, well, at this point we don't care. Let's just put this module here, kind of thing. And in the future, we're going to have to say, oh, we do care now. We need this module to be accessible only from this point, because we only want this system to be referenced at this point. So things will change. And that's why it's a sandbox, because there are a lot of changes to make. Code's simple. It is something I've looked at already, and I think that this base code will suit us fine. Absolutely fine. We haven't really messed around with the library yet. Maybe we should mess around a bit with the library. Use our library, maybe? Witch's Dusk. Yeah, I do usually program dusk till dawn. That's the joke. Obviously there's a reference there as well. But I think we can probably tick these off. I think it's expandable. We have done that. We've actually reached our initial goal to a point. We've tried out SFML. Are we implementing a structured approach? Yeah, I think we're splitting our files and things properly. There's more to that. Structured approach doesn't mean splitting files, even though that's what I do. Structured approach really means keeping your data separate from your functionality, which is going to be one of the biggest goals we're going to try and achieve, and we probably are going to use ECS to do that. It's how you structure the whole application rather than just these little bits and pieces which I'm splitting down into a jigsaw puzzle for myself, because that's what I can cope with. So, Rust specific, I wanted to make clear for myself why you needed crate when using application info. Crate. I mentioned super, didn't I? This super thing goes up one directory. That goes up into the application directory. What happens if I want to go to the source directory? I'd have to put super. Well, we can replace that kind of idea with the word crate. Crate means the top source directory. So this one here. So super will take me up one, crate will take me up to the source directory and then come back down. So I could replace that with crate, application, yeah, kind of thing. If you could, there's two ways of going about it. You can either go from bottom up using super, or top down using crate. It's a way of traveling through your file tree. Hope that makes sense. So this is going application, please. So this is going from the top level of our source code down to application. Just happens to be in the top level of our source code, so it was there directly. Whereas the word super would have gone from the bottom, where our application RS is, and gone upwards through the tree, the file tree. So it's how you access your file system. If we hover over it, it doesn't. Yeah, it just says crate is dawn. So it's dawn. You don't put src in because it knows it's in the src. So that is where that src can be renamed as crate, or be thought about as your crate is all contained in here. That's the best explanation I can give, really. Or that's my understanding of it, should I say. Yeah, I could have used super. Probably. Wouldn't need it because it's supposed to be, yeah, it's in the same directory, is it? I don't know. I can't tell with this thing half the time. Yeah, it's in the same directory. So that's why I'd thought, maybe I can take crate off. and he didn't like it. I don't know why, because it's in the same directory. That just doesn't make sense to me. But hey ho, doesn't make sense to me in this use case. But it wanted it, so we put it in. It just means it's in this source directory. That's all it actually means. It wanted that information, so we gave it that information. A bit weird, but yeah. Anything else? Yeah, super comes from below, crate goes from above. I think that's the easiest way of putting it. How does our cargo toml look? Yeah, SFML 0.24. I'm not going to think about that. Our git ignores okay. We haven't really put anything in readme. I'll probably start filling that in during the week as well, and start putting the references in to reference different things. Might be a good idea. I don't really want to do it right now. No, it's going to clock that up. I'll do it over the week. Start putting the reference material together, because I'm going to need it. I am going to need it. I don't think the reference materials are simple. I found that with all of the crates and also the standard library that they don't tend to explain themselves very well until you know how Rust works. I think I need more experience with Rust to be able to understand them fully. And I'm relying more on samples and sample code and working things out. We'll see. We'll see. Right. I'm planning to make this into a lib or just a structure to copy reuse. This sandbox I am going to do as a complete application. The library aspect of it can be reused separately. So Dusk, the library here, which has nothing in it, just some garbage that it automatically put in. Whatever we put in here can be reused in other applications, obviously. Reuse of this application itself, I think yes, at a basic level. What we've done so far is reusable in any application. So this part of it, yes, reusable. But eventually we're going to get more and more specific to the application itself. And that will change the ideas a little. If we can keep the files separated, then we can transfer files out. So the main file, info file, application file, input renderer, and a window API currently, and main RS, all of these files currently can be used in any application. That may change. The most generic code will go into our library. This is guaranteed to work in any other application, and that's why I'm using a workspace, so that I can have access to two different approaches at the same time, as we will hopefully see. We're going to do something simple with the lib, nothing complicated to start off with. Right. Yeah, I like what we've got. So I think we're going to leave it at that. And then on Sunday we'll probably look more at the state machine. Maybe start off by using our lib just to show you how it can be used. I think that's more important. But I've always programmed with, in this kind of style, always, with one application, the executable, and then a second project attached to it with a library where I can put stuff that I can use in different projects. In the meantime, I'd like you all to take care. A big thank you for popping by, and thanks for the questions, it is appreciated. I don't know too much about Rust, so take things with a pinch of salt. Don't hesitate to look it up and get it right. I know I do, but yeah. We'll get through it. We'll get through it. We'll have a nice little application going quite soon. I hope. We might get... I'm not going to promise moving things around on the screen just yet, because we do have to get to the ECS before we do that. State machine short. Use our lib is short, so we might be getting to the ECS on Sunday. We'll be bordering it on Sunday. I do want to use an ECS. Alrighty. 11.2, wow. Go me. Half of that's Windows. Right. Take care. Go and have some fun. And on Sunday I'll be back with some strange stuff.